All right, so first section we're going to take a look at this week is 1.1. We're going to look at it today and tomorrow. So 1.1 is on solving equations using addition and subtraction. Okay, very simple. We call them one-step equations. It means you only got to do one thing to get the answer. Now, some of the things that I put on the board, I'm just going to have you look at them. You don't have to write them down. Okay, so this first thing, you don't have to write this. I just want you to see what it means, and you guys already did it in the warm-up. When we added a number, let's look at like number 3. Where did we have to add a number when we added it? Where did we have to do it? Yeah, James?
To the side without a variable. To
the side without the variable, okay. And? Yeah?
The side with the variable.
The side with the variable, right? We had to do it on both sides. That's all that this property says, and you just have to read it. We don't have to write this one down. The addition property of equality says you are allowed to add the same number to both sides of the equation. And it doesn't mess anything up. Okay? But you have to add the same number to both sides. And it won't mess anything up. Okay? So let's look at this equation. X equals 6. Okay? Again, this one you're just looking at this. Very simple, right? X is already by itself. Now, I'm going to add 3 on both sides. If I add 3 to the right side, what do I get?
63.
If I add 3.
3x equals...
No.
So just start just on the right.
3 plus 6 and 9 equals... 9 equals 3 plus 6.
So if we added 3 on the right, you would get 9, okay? What if you added 3 on the left? Can you combine a number and a letter?
No.
No, so what would you write if you put
X plus 33 plus X.
just 3 plus X, or X plus 3, same thing.
You say 36. No.
Now,
I say 36.
does everyone agree we did the same thing on both sides?
Yeah.
Okay, so what's the answer to this bottom equation? What would you have to plug in for X to make it true? Yeah.
X equals 6.
X would equal 6. What about the first equation?
It just told us that.
The first equation was also X equals 6. These two equations have the same answer. That means they are equivalent. And that will always happen. Okay? Because you added the same number on both sides.
How'd you know to add 3?
Well, you could have added 3, you could have added 4. You can add any number as long as it's the same on both sides. Okay? So adding the same number to both sides of an equation will give you a new equation that has the same answer to the original. So our goal is usually to take something that looks complicated and make it look simpler. That's what we usually want to do. Okay? We did it a little different here, but what we're going to usually do is make it simpler. All right? All right. So now on your guided notes, okay, right at the top. To solve an equation means. Okay, before I show you, anyone think they can tell me? What does it mean to solve an equation? What do you got to do? Yep, Amy?
To find the answer.
Okay, find the answer. And how...
Come to a conclusion.
So how are you going to find the answer? What do you have to do? Think about the 3 warm-up problems we did. Yeah, Patriot?
You gotta evaluate or not.
So evaluate is when I give you a number and I say plug it in. These kind of problems we did in the warm-up, I didn't give you a number and have you plug it in. What did we have to do in those 3 problems? Yep.
Find out what the variable is.
And how do you find out what the variable is? What do you have to do with the variable? Well, we did it in these 3. To find out what the variable is, you have to...
Isolate the variable?
Exactly. You have to isolate it or basically get it by itself. Okay? So to solve an equation means to find a solution. And actually, there's a second part right here. You guys can just try to squeeze it in below that line. To solve an equation means to find the solution. So you just have to write to find the solution, what's highlighted in yellow. And then right after that, put, when solving an equation, get the variable alone. I mean, you can put on one side if you want, but the idea is get the variable alone. Or the way Patriot said it, he said isolate the variable. Perfect. He's using fancy words.
Yeah, that's all for one stuff right there. Balake told me how to say it.
Or did he? Big brains.
Okay, so what we're going to have now is I'm going to give you guys some steps. All right? A lot of people mix up PEMDAS and solving an equation. Okay, they're two different things. PEMDAS is arithmetic. So when you've got a problem like 2 times 3 plus 4 divided by 5, that's PEMDAS. That's not solving an equation. Solving an equation, that's like what we did in the warm-up. And the steps are a little different. Okay, so the steps I give you today are going to be the steps that you also use tomorrow. Now, not every single problem we solve has every single step in it. Okay? Problems we do today are going to be very, very short. Some equations are longer. Okay? Not every single problem has every single step in it. Okay? So, once we solve this part, you can just look at this. You don't have to write this down. But once we solve an equation, we're going to check it. How do you check it? That's what I think Patriot said. That's evaluating. You're going to take your number, you're going to plug it in, and see if it works. Now, we're not going to check every single problem. Okay, I may give you like 1 or 2 on the test to check, and then the rest of them, I'll say it's up to you. If you want to check it, you can check it. If you don't want to check it, you don't have to check it. Okay, but there will be a couple that you have to check. Now, do you think it's a good idea to check it if you have time? Yeah, if you check it and you find you did something wrong before I find you did it wrong, that's always good, right? If you figure it out first. All right, so to check your answer, can someone remind me how you do that? If you did that like last year in 8th grade, what do? You take the answer you got and what?
You so you got like x equals 3, you plug in 3 for x.
Exactly. It's exactly what you do. You take your answer and you plug it back into the original equation. Okay? If you don't know how to check your solution and you want to put a note how to do it, you could probably squeeze it in like up at the top to check your equation or to check your solution. If you know how to do that, I don't worry about writing it. But to check your solution, take the answer that you got and plug it back in for the variable. And it might be an x, might be a y. I think we did one in the warm-up, it was like k or something. Okay, but take your solution, plug it back in. Now, when you plug it in, and this will make more sense when we do it, you're hoping for a true statement. Okay? An example of a true statement is this. 3 equals 3. 7 equals 7. So you're going to end up with something like that when you check it, if you solved it correctly. Now, if you ended up with something like this when you check it, well, it means one of two things. Either you made a mistake when you checked it, or you plugged in the wrong answer. Okay, so you got to go back and try solving the equation again. Okay. But that's what you want to end up with. 3 equals 3. Okay. Any question on that? Well, we're going to do a couple then. Any question on what the directions are saying? So, one-step equations, all right? Now this is where you guys want to copy these down. Let me, yeah.
Sound like a dolphin.
Okay, so you've got some bullets. Okay, we're going to go through those bullets together right now. So on the first bullet, okay, and I did this with you guys in the warm-up. First step is to find the variable or the letter on one side of the equal sign. basically just figure out what the letter is. Sometimes I even circle it. Yeah.
It says something different. The paper to that.
Oh, on yours, it probably should, is this a 1?
Yeah.
Yeah, that should be a 1.
Oh my god, look, that's why you have to distract the class like that.
Chapter 1, Section 1. Yep. Thank you. So find the variable in the equation. Blake, what's the variable here?
X.
X. Where is it? What
On
side?
the right side.
On which side?
Wait,
Oh my god.
there's no way that's the left. Wait,
Yes, it
oh,
is.
yes, it is.
That's the left, yes. That's your variable.
I know this is like preschool.
Left? Right.
Now, if you want to circle,
Oh,
It's almost preschool.
I thought you said you know.
okay, if you want to circle it, you can. You don't have to, but just make sure you know where the variable is. Next thing is you move the number that's on the same side of the equal sign to the other side. Now, when I say same side, I mean the same side as the variable. I can add that in if it helps. Move number on same side with variable. So move the number that's on the same side with the variable to the other side. Now, what did I say? When you want to move it, you always have to do the opposite. Yep, opposite. So opposite operation. Okay. We're dealing with subtraction in this problem. What would be the opposite operation?
Addition.
Addition. Those are the only two operations we're going to look at today. Addition, subtraction. Tomorrow we're going to throw in multiplication, division, and then we're going to start getting into equations that have more complicated steps. Yep, Aileen, you had a question?
What's the on the first part where it's like find the variable? What's that in the parentheses, like the V?
Oh, with variable. So that's with variable.
Well, that was two.
Is that a W?
Yeah, just my pen's a little thick, so it doesn't write nice sometimes. Yep. So move the number that's on the same side with the variable to the other side. Which operation would we use here? Add or subtract? Add. So let's do it. So under example 1, you've got a spot right on the right-hand side. We'll do the steps right there. In fact, if you want, I'll just put it over there. Add, what am I adding?
X and 12.
No, you're adding 12.
You're adding 12.
I said 12.
Yep.
I said X and 12.
But I also said 12 was in.
Where, okay, where else do I have to add it besides on the left?
On the right side.
On the right. Okay, how about, is it Leilani? Yeah, what's going to happen on the left?
You put the X down.
How come? Well, what happens to the negative 12?
It cancels out.
It cancels out, right? Negative 12 plus 12. Gone? Bring down your X. Right-hand side. 9 plus 12. How much is that going to give you? 9 plus 12. 21. Okay, that's our answer. Now, for some problems, that's as far as we're going to go. What did I say we're going to do on a few problems? To just see, make sure we get the right answer. We're going to check it, okay? Check it. What does check mean? Check basically means evaluate using the number you just solved for. Evaluate using the number you just got. Now, what does evaluate mean? Let's say we forgot what that means. Evaluate means, what do you do with the number? Yep.
Plug it in.
Plug it in.
For the variable.
Yeah, exactly. Just plug it in for the variable. Okay? So what I usually do when I'm checking it is I just write down check so that I can see, okay, now I'm checking. Copy down the original problem. X minus 12 equals 9. How about, Olivia, what do we get for X?
3.
So when we solved equation, example 1, what did we get?
21.
21.
But what did... Actually, never mind. I was adding. I'm sorry.
Yeah. Yeah.
Oh, you subtracted.
So
But wait, no. Isn't...
so we got 21 for x.
No.
Everybody agrees with 21? So now plug 21 in. What I usually do is I put a question mark there because I don't know yet. That's what I'm figuring out. Does 21 minus 12 equal 9? So,
Yes. I did
Yeah.
math.
Teacher, you're supposed to know.
21 minus 12,
That's what she's gonna call.
and it does equal to 9.
Oh my god, I can't breathe.
So, how do we know that the answer's right?
Because you checked it.
Because I checked it, but how do I know, interpret what is that? 9 equals 9? What does that mean? Yeah.
It's back.
So you just subtracted what you got for your answer and the other stuff and equals 9, which is what you were trying to find.
Yeah, so we ended up with a true statement. Remember I said you might get like 7 equals 7 or 3 equals 3. We got 9 equals 9. That means we solved it correctly. Okay? Now, if we had gotten like 9 equals 8, what does that mean? What could that mean?
The answer that we got was
Could mean the answer that we got is wrong. What else could it mean? If you got 9 equals 8 or something like that.
You checked it right?
You checked it wrong. Yeah. So if you don't get the same number on each side, you either got the wrong answer, or when you checked it, you made a mistake checking. Okay? All right. So example 2, solve and check. Now, this one looks a little different, right? Because the variable's on the right. That's fine. Let's just leave it on the right this time. Okay, I showed you guys before, if you want, you can switch everything. And some people like to do that. Okay, take what's on the right, copy it all to the left. Take what's on the left, copy it to the right. Okay, I'm not going to do that on this one. Okay, the one downside of copying it is you're now doing one extra step, and then if you copy it wrong, then it's now messed up. So I just leave it the way it is. All right, so solve. Step 1. What's step 1? Make sure you can identify the what.
Variable.
Right, what's the variable here?
Y.
Y. Okay, so we know that's what we want to get by itself. Okay, let's look at our next step.
Don't ask what it is.
Move the number on the same side with the variable using the opposite operation. So the first thing, how about Elizabeth? What's the number on the same side with the variable? -4, perfect. She said 4, but then she put the negative with it. The sign to the left always goes with the number. So we know what we want to move, -4. How do we move it? What do we have to do?
You gotta add 4 on both sides.
Add 4 on both. So he said 2 things, perfect. Add, which is the opposite, and then do it on both sides. Okay. So when I do that, start with -4 plus 4. What happens there?
It cancels out when you get 0.
Yeah, it cancels out, it becomes 0, so I usually cross it out. Now, the only thing I have on the right side, I just have to put something right here.
Can I go to the bathroom?
Yeah. What do I have to put on the right side? The only thing that's left, yeah? Just the Y. Okay, and now the last thing we've got is simple addition. 3 plus 4. How about, Tristan, what's 3 plus 4 going to be?
7.
7, yep, good job. Now, if you put 7 equals Y, that's the same as what?
Y equals 7.
Yeah. If you had switched it and wrote it like that, that's fine. I don't care which way you write it. It's the same thing. Okay? Now, Gianna, are we done? No, what else did it say to do? We did half the directions.
Check.
Yes, Gianna. Oh, you're Gianna now. So Gianna said we're going to have to check it. All right? So when we check it, you guys don't have a ton of space, but
Typical block.
just come maybe off to the side or just squeeze it in wherever you can. Let's check it. Okay, so to check it, what do I have to do? Yes, is it Lily? Yes.
Put a 7 where the Y is.
Put a 7 where the Y is. What about everything else?
Keep it the same.
Keep it the same. 3 equals 7 minus 4. You don't have to put a question mark, but when I'm checking, I do, because that's the question. Does what's on the left equal what's on the right? What's on the left? It's just 3. How about 7 minus 4?
3.
Perfect.
3.
Okay, since we got the same number on both sides, that means it's right. Okay, any question on that one? All right, I think what we'll do, all right, I got one more we'll do together. Then I'm going to give you guys one try on your own, and then we'll finish up with a word problem together. All right, so example 3. $12 equals x minus 5. All right, so Kayla, what's my variable here?
X.
Perfect. X, how about Maya? Is the x by itself already? No, if it was, we'd be done. Right? If it said x equals and just a number, we wouldn't have to do anything. Okay, so Maya said it's not by itself. Sophia, what is with the x that we don't want? Yep, we don't want that minus 5 there. And Blake, how am I going to get rid of the minus 5?
Plus 5.
So he said plus, I agree. Where do you have to do it?
The right side.
Just like that?
Yep.
One more place.
The 12.
Yep, you're going to do it on the 12. All right. How about Mackenzie? What's negative 5? Plus 5. Yep, 0. Okay, you don't have to put the x through it. I usually do that when it cancels out. But if you don't want to, that's fine. Princess, what's on the right now? Oh, well, the 5 is gone. So what else is still on the right-hand side? The what? So 12 plus 5, that's going to be on the left. The x. Okay? So we've got the x on the right. And now 12 plus 5 on the left. How about Eileen? What's that going to come out to?
17.
Yep, 17. Now, do we have to check this one? Yeah, just read the directions. The directions are not on your guided notes, but you can. It's solve and check for pretty much most of the ones.
Do we check for our homework too?
There'll be some. I will tell you which ones you have to check. You're not going to have to check all of them. There's 11 problems. I might have you check like 5 out of 11. So a little less than half of them. Because I don't want you to have to check every one. All right. Check it. Okay. How about Adriana? How do I check it? Do you remember the first thing you have to do to check a problem? You have to take what? I can't. Yeah, okay, so take your equation here, yeah. And anyone help her out? How do we check it? Just like we get example 1 and 2. Yes, Cadence.
You're going to want to put the answer you got for the variable in place of the problem.
Right. Take what you got, plug it back in for x, and the hope is when we're done we get like 5 equals 5 or 9 equals 9, something like that. Okay, so let's check it. Right, so Blake, tell me how to finish, what do I want to write now when I check it?
12 equals 17 minus 5.
Yep. And I'll put a question mark because That's the question. Does 12 equal 17 minus 5? So now I'm asking you.
Yes.
Yes, it does.
Yes, it do. It do be doing that.
Eight.
So 12 equals 12. We're good. Okay. So we've done 3 now, solve and check. No matter what, I think that if the directions on number 4 say to check, we'll just solve them. Okay?
Fair enough.
So in number 3, we added. In example 2, we added. In example 1, we added. Let's look at an example where we subtract. So and this, I just want you guys to read this. You don't have to write this part down. If the addition property of equality says you can add the same number to both sides, what do you think this one says? You can subtract what? Anyone think they can tell me what it says? What number? Yeah, whatever it is, right? The same number. So you can subtract the same number from both sides, and you'll get an equivalent equation. Equivalent just means that you won't mess anything up. Okay? As long as you do it on both sides. Now, we haven't gotten to this yet, but when we multiply, you can multiply both sides by the same number, except for one number. Does anybody know what that number is? You cannot multiply both sides by, because it kind of wipes everything out. Yeah, 0. We don't have to worry about it today. But when we get to multiplication, you can't use 0 on both sides. Yeah.
I have a paper.
Okay, I can grab that after.
That's like a week old.
Yeah, it's on the game.
But I forgot it, and then I had it signed in.
All right, so example 4, I want you guys to take maybe like 30 seconds and solve that. You don't have to check it. Okay, just solve it. So take like 30 seconds. So anybody tell me what's the operation that I have to use? Just tell me that first. Yep. Subtraction. Patriot, can you tell me what I need to subtract?
You have to subtract 6 from both sides.
Perfect. So he told me what to subtract. He told me where to subtract it.
Oh.
Plus 6 minus 6. What's that come out to?
0.
Or
0.
oh,
4.
I was talking about the other one. I thought you were on the other one.
Okay, we're gonna get there. 10 minus 6. Blake just told us, yes, that is 4.
I saw 7.
Any question?
I made Blake sad.
Everyone okay with example 4?
Yes.
Okay. So let's try example 5. Now, you're gonna see a few phrases that come up a lot. Okay? So I want to make sure you guys know what those mean. So if you don't know what this phrase means, you could probably squeeze it in like on the right-hand side on example 5. For more than a number. Okay, if you know what this means already, you don't have to write this down. How would you write that? For more than a number. Yeah, go ahead, Joe.
N plus 4.
Yeah, n plus 4, x plus 4, n plus 4. Or, with addition, it's okay if you switch the order. Okay? And if you ever forget, just take 2 numbers, add them in your head, switch the order. See if you get a different answer. 2 plus 3, 3 plus 2. Okay? Same thing. How about 16 less than a number? Now you got to be careful. Okay, when you have less than, you've got to be careful of the order. Now, if you're stuck, pretend like it said 16 less than 20. So think in your head, okay, what's 16 less than 20? And then think of what you would do to figure that out. If somebody didn't understand, you say, oh, you do this minus this. Yeah, Patriot?
N minus 16.
N minus 16. Let's check. Perfect. A little tricky. The reason I think it's tricky is because 16 came first. Number came last. That's not the order you write it in though. So whenever you see less than, like 2 less than 10, if I wanted to figure out, okay, what's 2 less than 10, I would do 10 minus 2. That's how you do 2 less than 10. It's kind of like it's backwards. Okay? Any question on that? Okay, so we're gonna get other phrases that come up, but those I think cover. Actually, we have one more. How about a number decreased by 16? A number decreased by 16. So think in your head, like 20 decreased by 16. How would you write that out?
Right, not that line.
Yeah, James?
Wouldn't it be the same thing as the last one?
Well, what is 20 decreased by 16? How much is it?
4.
4. So, if you did it like the last one, let's see, a number decreased by 16. Yeah, I think you're right. It's going to be the same thing.
10 minus 16.
Yep, perfect.
Garbage go.
So, when you see decreased by, you don't have to switch the order. Number, decrease, 16. Number, decrease, 16. Any question on that? So let's try a word problem. And then I'll have you guys do the pretest. So it says the price of a shirt was X dollars. Do you guys already have this written? Okay.
Yeah, sure.
Now, sometimes I may change the number. Like I may have had like 42 instead of 32. If you ever notice the number is different on your guided notes, just let me know. We'll fix it. So it says the price of a shirt was X dollars. The price was increased by 7 and is now 32. Write and solve an equation to find the original price. So I'm more interested if you can figure out how to write an equation than actually solve the whole problem. But just underline some important things. Can anybody tell me something that's important here? Words, numbers, there's some of each.
32.
32.
The price.
That's going to be important. What else? Yeah? Increased. That tells you an operation, whether it's adding or subtracting. Couple more things that are important. Yep, Kate?
$7.
$7. One more word there that's important. Yeah.
Was.
Um,
X dollars.
So sometimes was is important, like when we talk about problems in the past. We're not going to really look at that for now, but what's the present tense of the word was? Is, right? Was is past tense, is present tense. And I think that's everything that's important, unless, yeah?
$X.
Yep, so X is important because that's our variable. So it says the price. What's our price going to be represented by since we don't know it? Sometimes you can pick it. Bless you. Yeah.
X.
Yep, the price is going to be, that's going to be represented as X. So it says the price increased by 7. So how would you write price increase 7? What? Yeah, Patriot?
I said X plus 7.
Perfect. The price increased by 7. Now, this is the word here that I said is important. Does anybody know what is means? Was means the same thing in the past tense in math, but is present tense and it means, yeah? Equal. Yeah. Equals. So price increased by 7 is how much? 32. So on a test, if you got that far, I give you half credit for that. Because you got the equation set up. Now the other half would be, can you solve it? If all you did was solve it and give me a price without showing me an equation, I'd give you half. Because the problem said write and solve an equation. Okay?
What did you do to the lake?
So, what's my last step here to get x by itself? Yeah,
Isolate the variable.
nice
by
job.
Subtracting 7.
I like it.
Using big boy terms.
Subtract 7. How about Lucas, plus 7 minus 7, what happens?
We cross it out.
Cross it out, it's gone. The only thing on the left now is x. And on the right, 32 minus 7, Joe?
25.
Nice job. Now, this was a word problem, so we might need a label. 25, what? Dollars. We're finding the original price, which was in dollars. Perfect. Okay, any questions on that? All right, so I'm gonna put up a couple reminders. I think they're things I already told you, and then we'll do the pretest. So tonight, I'm gonna give you guys a worksheet. If you didn't get a binder, bring one in by Thursday. I'll help you with the dividers. Chromebook, we're gonna do that whatever day we have time. So how many people usually have their Chromebook pretty much just with them every day?
Yeah, I just forgot it because I left it charging.
Okay.
I woke up late. I almost missed the bus.
So bring your Chromebook for tomorrow. I think we're gonna have extra time just like today. We'll probably do the Chromebook thing tomorrow. And then our first test will be on Friday.
Are we doing the rest tomorrow?
That's 13. Yep.
What time is this class?
So save your guided notes because we're gonna fill the bottom in tomorrow.